Okay, in the last video, we found the interval of convergence, and we showed that it was -1 to 1, not including -1, so an open interval, but including 1. Okay, I'm going to do this two different ways. Again, I'm going to use the root, and this is a two-step process. Well, this is the same for the ratio. What you do is you solve rho equals the root limit or ratio limit less than 1 for x. And the second thing is you solve rho equals 1 for x, and you plug in and hand test. Here, I'm going to say here that because of the root and ratio test here, the convergence is also absolute. We don't need to know that, but I'll point that out. Okay, so I'll use the root first, and I'm going to solve rho equals limit. K goes to infinity, kth root absolute -1 to the x to the k plus 1 over k plus 1. That's all absoluted. So that's going to be lim k goes to infinity. Absolute value of 1 is 1, of -1 is 1, so we don't need that. Absolute value of x, we do need that because x could be negative, but we know that that's always positive, and I like to write the limit this way. Okay, so I'm going to write two different limits, lim absolute x to the k plus 1 over k, over the limit k plus 1 to the 1 over k. Okay. This one is going to be the limit x to the k plus 1 over k, and this is going to be 1. We've shown that in class, so this is going to be the limit absolute x to the k over k, absolute x 1 over k over 1. Splitting this up into 2, this is going to just be x right here, and this is going to go to 1. And I need to solve this less than 1. So I'll continue this. So remember what my methodology is. I solve the root ratio less than 1. And then for x, that's where the convergence is absolute. And then I solve for x where rho is equal to 1. So here, right here, what I'm going to get is I'm going to get what this means. I need to solve this limit is equal to x, and I need to solve that less than 1. So I need to solve absolute x less than 1. Well, that's going to be, it's already solved really, but that's going to be the interval -1 to 1, endpoints not included. Okay, so I've done I've done step 1. So that means that interval convergence is at least -1 to 1. So that's step 1. Now step 2, I solve rho equal x equal 1 for x, and I get x is equal to -1, 1, and now I have to hand test at x equal -1 and x equal 1. I'll do that again. I've already done that, but I've already done that again. So, but we'll do that. So I'll do that on the next page. And I'll come back and review everything. So that's where we are there. So I'm going to to plug in x equals 1. I get this series. Oops, let's see what the original series was. That was the original series right here. So let's write that down. And I get k is equal to 1. Oops, I forgot the k there. Minus 1 to the k, 1, k plus 1, over k plus 1, equals the alternating series, minus 1 to the k, over k plus 1. Sorry, these should have been k is equal to 0 and k is equal to 0. Whew, sorry. And this is an alternating series. We've done this a couple of times, so I'm going to skip it, but terms decrease. This limit, minus 1k, I guess I'm not skipping it, k plus 1 is equal to 0, so it converges. Okay, so now we know we have convergence at x equals 1. So we have convergence at least here, and it also converges here. So now I'm going to test x equals minus 1, which we've done before, but I'll do it briefly again. So I'm going to plug it into the series, this series right here. Sorry, it's minus 1 to the k from this, and then minus 1 to the k plus 1. We saw before that this is equal to minus 1 over k plus 1. The way that I think about it is minus 1 to the k. That makes it negative when k is odd. This makes it negative when k is even. So that means it's always going to be negative. And this, we showed that this diverged. This is just the series minus 1, minus 1, minus 1, minus 1. So that's going to be minus infinity. So it diverges at x equals minus 1. So the interval of convergence is, we start off with minus 1 to 1, which we got earlier. We don't include this endpoint because it diverges, but we include this endpoint because it converges. And we're done. Yeah, I'm going to do a different interval of convergence for the ratio test.